Hello, my name is Brett Champion. I'm the visualization manager here at Wolfram, and today I'm going to be giving a very quick and fairly scattered overview of what is new in visualization. So the first thing I have to define is what I consider new, and I'm going to be looking at anything that was introduced in version 10.1 or later. So through version 11, this gives me about a year and a half's worth of material to cover in about 20 minutes. So I'll start off with my precious time by advertising some related visualization talks that are going to go into more detail on many of these topics. So immediately following my talk, Min Chuan is going to be talking about improvements to the core visualization functions, plot, list plot, this family of things. At 3:30 today, Emmanuel is going to be talking about geo-visualization. J-Bum is going to be talking at 5 about 3D printing. Nirmal is going to be talking at 5:30 about date visualization. Tomorrow at 11, Jeff and Keiko will be talking about anatomy plot 3D. And on Friday at 4, Yutsu is going to be talking about graphics 3D improvements in general. So we're going to cover a wide range of things today, going from the basics to date and time, volume visualization, geography, anatomy, text, improvements to themes, and we might even get into some stuff past there if I'm efficient enough with my time. So starting with the core functions, there's not so many new core visualization functions, but we've been sweeping back and making passes and pushing improvements and new options out across all of them. So the first one I want to talk about a little bit is scaling functions, which is now supported by list plot, date list plot, plot, and derivative functions of that. So, and in addition, a lot of the existing functions that do scaling, such as log plot, have switched over from sort of independent code to relying on this functionality that we've built into the main plots. So here we have an example where I'm just plotting x from 1 to 100, and I've applied a log axis, or a log scale to the y-axis. And I've reversed the x-axis. So instead of numbers getting larger as you go to the right, they're getting larger as you go to the left. The next one is exclusions, which between Adam before me and Min after me, I think they'll both have a much wider and cooler set of examples. The key part, as far as I'm concerned, for a lot of people is going to be that for simple functions like 1 over x or tangent of x, we're now going to be showing, we're now detecting where those singularities are and are able to remove the lines that would have been present in previous versions. In version 10.4, we added a new option, plot labels, and this applies to plot, list plot, date list plot, the logged variants. Eventually, we hope to push it out to some of the parametric plot and maybe even some surfaces, but we have to figure out exactly how we're going to do some labeling in those cases. Requires a bit more research. So this is an option, and we just say what our labels are, very similar to legends in this case, and then by default, it's just going to put them down the right-hand side of our plot, sort of labeling the curves directly. In version 11, we introduced callout, and I'm sure Min is going to talk about this in much more detail. In the meantime, I've stolen what I think is the best example for my talk. And so this is a wrapper that works within plot, list plot, a lot of the curve generators. The basic syntax is the thing that you want to apply the callout to, whether it's a point or a line. What you want the callout to be, in this case, it's the same thing. Where you want it, and then I've just got a bunch of styling options, including an appearance option that says I want it to look sort of like a balloon, and then each of those curves is getting a fairly fancy looking box identifying it. Yes?
The call-out label, is that automatically done in traditional form, or what's going on?
That is automatically being done in traditional form.
Are you
Mhm.
able to position the call-out or point it to a particular knee in the curve or a point in the curve?
Yes. And Min will go into that more. If you, in this case, I've just said above and below, and it's automatically looking at the curve and trying to figure out where a good position above it or a good position below it is, based on where the other curves are and where extremas are and that sort of thing. So now, moving on to date and time. So here we have, well, we'll start with timeline plot, which was introduced in version 10.1. I have an association of the release dates for versions of Mathematica. I need to update the documentation with the most recent releases. I think the example in the timeline docs currently stops at 10.3. And so here we have all of those releases arranged on a time axis, and they're sort of cleverly routed so that all the labels line up fairly nicely, both vertically and horizontally. It supports multiple different types of layouts, and so if I switch to packed, then the labels are a little bit more tightly spaced to each other. And you can really see, where we've started ramping up the release process in the last couple of years. Another time and date visualization that we've added recently is date histogram. So here I've used a new, in version 11 I think, function called file system map to get the creation dates of all the notebooks on in my desktop. And I'm limiting it to stuff after 2010, just to make it slightly more interesting, I think. So there's about 1,000 files. And we can say, create a histogram by year, and it's going to show me that, in general, it's been increasing, and I'm, about 200 notebooks that I've put on my desktop so far today, within various folder structures and whatnot. I don't have 1,000 notebooks just all thrown together on my desktop. In fact, my desktop is completely empty at the moment, except for the talks and conferences notebook that I didn't dare move. But the cool thing about date histogram is we also added this date reduction option, which allows us to say things like, all weeks are the same. And we just want to look within that set of dates. When am I creating notebooks by day of the week? Or within a day, what times am I creating notebooks? So most of my notebooks get created in the afternoon, but between 11 and 12, I'm really productive. And the other one that I was introduced in 10.3 is dateless step plots. This is similar to date list plot with interpolation order goes to 0, except that it's going to automatically extend out so that on that last data point. And so here we have the top 10 girls' names from the US Census, or is it the census, or maybe it's Social Security? I forget who gathers that data. And it had changed since I last ran this a couple of months ago. So Harper was not originally on the list. So we must have gotten updated data at some point recently. So anyway, then we rank them, and now we get sort of very nice step plots, and you can see that Emily was really popular, #1 for 10 years or something, maybe almost 15, but has taken a steep dive in the last 7 or 8 years. And so now Emma's at the top. So now we'll look at volume visualization. At the conference last year, they put me on a stool and spun me around and took a scan of my head. It took a long time to get the results out of the geometry team. But eventually they did give it to me. And so now we can do things like this. So I have a density plot 3D of some function that is rather arbitrary and not at all flattering to my appearance. But I can plot over my head, and not just over the surface of my head, but over the volume encased by my head and shoulders, this function, and sort of see what happens internally for this function over space. And I didn't turn the legend on, so this isn't immediately obvious, but in addition to using color, we're also using opacity. And so we're picking out what areas we think are sort of most interesting. And by most interesting, by default, it's what's the smallest range of values that covers the largest amount of volume. And so those we make more opaque. Everything else we make nearly transparent. And so in this case, you sort of see blue, dark blue blobs and sort of dark yellowy orange regions that are more opaque. And in the case of this function, those are near 1 and -1. We also introduce slice plots so the underscores here represent density, contour, and vector. I'm looking at density. And we can take that same function and look at what does it look like on different surfaces within that volume. So we're looking at various fixed values of x, still within my head and shoulders, and look at what a normal density plot looks like on those surfaces. And then for fun, we can combine them and sort of see where. So if you look sort of down here near my left shoulder, you can sort of see where there's a more opaque blue region, and it matches up nicely with the blue density on the surface, on the slice surface. So now in 10.4, moving on to geography, we introduce dynamic geographics. So this behaves largely with the same syntax as geographics, the static version, except that I can zoom and pan. So here we have a path that takes us from Miami to Seattle, and we're making sure to show the entire US because otherwise it would clip off Maine and probably parts of Pennsylvania. And if I've done this well, my data is already cached, so I'm not relying on the network. Well, the network was okay. And I can sort of zoom in to see, we just skirt around Paducah, Kentucky, cut up through Illinois for a little bit, and then head over to St. Louis. And in version 11, we introduced geohistogram. So here I have a data set that has a little bit over 4,000 locations in the continental US. And by default, we're using a hexagonal binning to show where more of those points are, where fewer of those points are. So there's sort of big clusters in New York. So that's, I'm sure the tooltip is not legible, so that's around 300, slightly lower, but still over 300 for Chicago, 213 for Denver, Southern California, 224. But the binning for this is very flexible. Emmanuel will go into it in a lot more detail. But we can also say that I want my bins to be US states, in which case then it will take those 4,000 points, figure out which state each of them is in, and color the state directly. In this version, you get something that ends up looking similar to a georegion value plot, except that requires you to have already done the counting yourself. This is just taking the raw points, doing the counting, and generating a similar looking graphic. So now moving on to anatomy, which was included in version 11. As I mentioned, excuse me, as I mentioned, Jeff and Keiko will be talking about this more. This is a relatively complicated example to start with. The basic ideas are I want muscles to be cyan, and they're going to get cut by a plane, cut away by a plane at some point. The skin is going to be a nice bright green. Again, the skin is going to get cut away at a different point, and the bones are going to be orange, and everything else is going to be transparent. And for that, we're going to show your left arm, including the skin. And so then we end up with sort of a very alien-looking person. I was actually sort of going, alien, Halloween's coming up, trying to make something that was a bit unusual. Not at all lifelike. If you really look like this, go see a doctor. I'm sure they're going to want to write articles about you. So then moving on quickly to visualization around text. So believe it or not, in version 10.1, we introduced a function called word cloud. You may not have seen these before. I think they're some people's favorite visualization to use when they can't think what else to use for various domains. So anyway, we got the text of the Raven by Edgar Allan Poe, threw it into word cloud, and it throws a big Nevermore right there in front of us, which is nice, but there's more interesting things that you can do. Like, you can take a picture of a raven and use that as a mask, and then it magically changes the colors too, or maybe not magically. And so now we've constrained the word cloud to be around this image of the bird, and hopefully it's still sort of visible. You don't get quite the resolution. Words are stubborn that way.
What if you want the words inside the bird?
If you want the words inside the bird, you color negate your mask so that it's a white bird inside of a black background, and that's what you end up with. So we also, this is perhaps stretching the definition of visualization a little bit, but added a function that will do sentence diagramming. So what's a verb, what's a noun, what's an adjective. It was not my favorite task to do in school. So once again, we'll feed it, the first sentence out of the Raven. It styled it a little bit. And then it goes off and does its thing. I have some quibbles with how it's classified some of these words that, I don't think dreary is a verb in this context. And I think, I'm pretty sure that pondered is not an adjective. So, it is marked experimental. So anyway, moving on to themes, we're getting close. So JBum will talk more about 3D printing in general, but one of the things we did is added plot themes to make it easier to create printable plots. The two main ones are filled surface and thick surface, which hopefully it's fairly obvious what each of those has done and self-explanatory. We added more auto-completions for plot themes. And so if I delete this and hit Command K to bring up the list, this is basically what it looks like in version 10, except that now it has these little arrows down at the bottom. And from there you can get a much more complete list of not just the main themes, but also the secondary ones. So if I want to do this as a filled surface, say, then that's there as an option. We also added themes for gauges to make the styling of them easier, for meshes, which Charles, if you were here for his talk, mentioned as well, and for graphs. So just about everything visual supports themes at the moment, and the ones that don't should be getting them soon. And so that's everything I put in the overview, but wait, there's more. So there's also, with the addition of the new audio objects, different ways of visualizing audio waveforms, dendrograms for looking at clustering of things. We added icons as various forms of entities, and so you can get an icon for a lighthouse or an airplane and include it on a map easily using GeoMarker. And then rule plot for looking at various computational systems like cellular automata in 1D and 2D, Turing machines, substitution systems, and there's probably some that I'm forgetting. And that really is the end then. So, thank you.